Hello guys, welcome to Thrill with Physics YouTube channel. In this video, you can learn about the basic concepts of Newton's law of rectilinear motion. Now let's start from the very beginning, that is first law, which shows the relationship of force and motion. In the past, a law governing the relationship between forces and motion was completely described by Sir Isaac Newton on the basis of law of inertia, which was given by Galileo, which says that if there are no external action on a body, it neither moves with a constant velocity or it is at rest. Newton later formulated this law as a body will remain in its state of rest or uniform rectilinear motion unless it is compelled to change its state by an application of external force. This means that if the vector sum of all the forces acting on a particle is zero, then the particle remains unaccelerated. That means it could be in rest or move with a constant velocity. Now, assume that this is our particle A, and the force acting on A is F1 and F2, which are equal and in opposite direction. Now, if we look at the sum of the forces, which is F1 plus F2, if this sum is equal to 0, then we can say that the acceleration is 0 and the particle is unaccelerated. Or we know that a particle is unaccelerated when we can be sure that the sum of forces acting on that particle is 0. Now, there is another way to look at this situation. If no external force acts on a system, the state of system does not change. For example, assume that we have two masses, m1 and m2, having the same value. Now, m1 is applying force in this direction and m2 is applying force in the opposite direction to m1. If we see the line of force, at this point we have center of mass. In this case, the external force is 0. And hence m1 and m2 remains unaccelerated. Now imagine what will happen in the case if m1 is greater than m2. Let's say this is m1, this is m2, this is the line of force. In this case, the center of mass will shift towards m1 and still the external force will be equal to 0. And we can say that center of mass is at rest. Now, what will happen if the system consists of more than one particle? Then, in that case, the Newton's law is collectively applied to center of mass. I hope you understand the concept of first law of motion. Now, coming to the second law of motion. Second law of motion says that the acceleration of a particle as measured from an inertial frame is given by the vector sum of all the forces acting on the particle divided by its mass. This means the acceleration on a particle is given by the vector sum of all the forces acting on it divided by mass. From this equation, we can say that our force is nothing but multiple of mass into acceleration. Now imagine if we have a particle C on which we have different force from different directions. Then the F will become, let's say this is F1, F2, F3, F4, F5, F6. The net force will be vector sum of F1, F2, F3, F4, F5, and F6. And since there is just one particle, so mass will be just 1. In that case, we will just substitute m is equals to mass of particle C, and in place of force, this whole equation will come into place. A force which is acting on the particle of mass m produces an acceleration of F by m. In it with respect to an inertial frame of reference. This is the law of nature. If the force ceases to act at some instant, the acceleration will become 0 at the same instant. In this equation, A and F are measured at the same instant of time. Now, if we look at some mathematical derivation of this second law of motion, we can say that the rate of change of linear momentum of a body is equal to the force acting on it. This means force acting on it is equal to rate of change of linear momentum. And we know that linear momentum is nothing but mass into velocity. This means force will be equal to, since mass is constant, we can take it out of the derivative, and force will become mass multiplied by the first derivative of the velocity. Now this equation is valid only if m is constant. We can also write this equation in different form. For example, if we change velocity to our displacement, then force can be written as m t square r over dt square, or d square r by dt square can be written as the acceleration. Now, what will happen in the case if the mass is variable? Then this law will change, and we will write it as a function of mass and velocity. So the equation will become t by dt of mass time velocity, and the final expression will be by dt. I hope you understand this concept. Now, what will happen if more than one force acts on the body, which consequently acquires acceleration of A? Then we can write that summation of vector sum of all the forces is equal to mass into acceleration. Now, this equation is the mathematical form of Newton's second law. And it provides for the general equation of rectilinear motion, which is the basic equation of classical mechanics. Now, there are 2 or 3 important notes to be taken. First is, Newton's first law is simply a special case of second law. Second is, both laws hold if the frame of reference has no acceleration. This means the frame of reference stays to be inertial reference frame. Now the third is a frame of reference in which Newton's first and second law hold is called an inertial or Galilean or Newtonian frame of reference. It's called Galilean or Newtonian or inertial frame of reference. Now we can move forward to Newton's third law of motion. Which says that if a body A exerts a force F on body B, and if B exerts a force minus F on A, then it will be equal. In other ways, to every action there is always equal and opposite reaction. Now, this also means that every force acting on a body always occur in pairs. Forces on body A and B are equal and also opposite to the force on the body B by A. Therefore, we can write force on body B from A is equal to force on body A by B. Now, the question comes, when can we use Newton's third law? So, Newton's third law can be used in non-inertial frame of reference if pseudo force are also included. A single isolated force is impossible. And the other note to be taken is one of the 2 forces involved in mutual interaction between 2 bodies is called action force and the other is termed as reaction force. So this one can be called as action. This one can be called as reaction. Now, we can say that third law speaks of mutual and simultaneous interaction, action and reaction forces which always occur in pair, act on different bodies. I hope this video was helpful for you to understand the basic concepts. If it was helpful, please like and subscribe to my channel for more such videos. Thank you.